Hello, hello. Give me just a moment to get ready. Welcome to the stream. Um, if you wrote something in the chat, I didn't see it because I don't know how to turn on. I moved to a different computer now from the last one. Whoops. And I don't know how to actually turn on this Twitch window in OBS. Let me actually Google it. I don't see it anywhere in the options. Yeah. Okay. Too complicated. I won't do it now. All right. So, give me just 2 minutes. I need to start my laundry machine. I'll be back. All right, I'm back. I'm completely unprepared for this stream. Okay, I can actually do this. Later. Okay, so welcome everybody to the stream. This is the 19th stream. Oh, I forgot to share it on Twitter. Just a moment. Okay, time to start. Oh, and even before starting, I knocked off my my microphone. Okay, so let's start. So, welcome everybody to the stream. This is the 19th stream, and this stream is all going to be about making a better sky, or, well, more precisely, the skybox, or the background. It's only called skybox because it has 6 sides on a as a painting, as a texture, as a painting. But yeah, in my case, I actually want to create a completely new one from scratch, a new shader, a new, better sky, better background with a custom earth shader. So this is going to be an interesting stream because for the first time ever, I'm going to. Oh, the outside is pretty noisy, by the way. For the first time ever, I'm going to make a shader in Godot. So I've never done it before. I only tried a little bit today, and I figured out that I actually need to do some there are 2 types of shaders in Godot. There's the visual shader, which is made by graphs, and then there's another one which is made by code. And I actually just today tried to do both, and I found out that the visual shader doesn't have a lot of features. So yeah, I am going to actually code the shader from scratch. So what do I want? Well, I want this. I want the background to have a nice sphere with a nice earth texture, just like this. Is everything okay? Yes, everything is okay. I wanted to have a nice sphere, right? You need to see the sphere, right? Not just this, which is like just a line that I hacked. This is just a skybox shader, and this is actually the ground. So yeah, in Godot there is no spherical planet, and on top of the Earth there should be a little bit of atmosphere that you see like at the edge, right? Just like in real life. And I want to implement this with, as I said, as a custom shader. So it's not going to be like some kind of a mesh that is going to be just like at a distance from, which is the way that a lot of people implement background planets, right? With just like putting a mesh in the distance. But I want to actually code it from the scratch. So this is going to be all implemented in the shader. And yeah, so let's begin. Let me just close all the windows because yeah, the street is pretty noisy. Okay, so first off, let's let me explain how shaders work. So in Godot, I found out that it is actually really easy to make your background shader. And you do that in your environment. So we'll find my environment. This is the player. Here it is. And in the environment settings, it is possible to replace the sky with a custom shader. There is the sky. It is a bit weird that it has like a background mode, and then you select the sky, and then the sky is an asset, and then the sky has a material, and then the material has a shader. So yeah, in this case, I'm using a procedural sky, which is how I create this. Oh, by the way, I completely forgot to submit everything that I did in between, but I don't have time to deal with to show you what I did before. I just want to jump straight into shaders this time. So let me just submit everything I did. Okay, that's gonna be it. Just so that I don't break something. That's why. And I actually added some buttons and switches yesterday, but I'm gonna show you that on a different stream, on some future stream. Okay, so for now we're solely focusing on the background shader. So what are we up to here? We have a procedural sky, right, that is currently assigned, and in it you can define different things like, oh, what color do you want the sky to be with? You want to make it a pink sky. There it is. Now space is pink. Horizon color, I can change it to some funky color as well, but the horizon actually doesn't exist. You can set the curve. Oh yeah, the curve of basically this is how I made the atmosphere, by sharpening the curve. And then you can of course make the energy go up. What is cool about doing this shader, doing a skybox shader, is that it is automatically applied as an ambient color to your environment. So here I have my space station, and look at that. It taints the purple color even on the inside because I have GI turned off. SDF GI, which I typically use, I've turned it off. But yeah, normally there is a it should be dark inside, of course, but I'm just using this to test my how it actually looks on the station. Okay, so now I'm actually going to replace this sky with a completely custom shader. Oh yeah, by the way, there is also this other thing which is like oh yeah, let's actually save this sky for future use. And the cool thing about Godot is that anything you set up in here in your UI, in your scene, you can actually export as a resource. So, well, I kind of ruined it now by changing these. Well, let's actually let's discard all the changes. So hopefully this is going to reload everything. Okay, let's see. Come on. Yes, there it is. Okay, so yeah, for the beginning, let me actually save this as a resource, and I'm gonna put it in, let's put it in environment folder. Okay, there it is. It's going to be legacy sky. Let's call it like that. Okay, so yeah, this legacy sky is now a legacy sky tress, which is the resource. Okay, so well, now I'm going to completely replace it with a new shader material. There we go, and look at that. Now it's completely black. except for the sun, right? Because there is sunlight, and the sunlight is, but there's no absolutely no ambient light. This is almost how it would look like if it was somewhere in deep space, you know, far from anything that can reflect light onto my spacecraft or the station. So I'm going to actually make now. Well, yeah, we have the sky material, but the sky material is just there to hold our properties. That's the only point of the material. But now I'm going to create a new shader, right? Actually, let's see if okay, I can't even have another shader because nothing else exists. Okay, let's create a new shader. And I'm going to call this my... should I just call it sky? But it's not really a sky. Okay, well, yes, it's a sky mode. Let's just name it like that. And yeah, let's put it in the environment and call it sky. Okay, there we go. Here we go. Create. We'll create a new shader, and there we go. And by the way, there is an option. Yeah, for the sky. There it is. It opens in here, and actually I find this quite interesting. Like, it has this shader editor is completely different from a script editor, because scripts are edited here. It's not like in Unity, you know, you just open it in Visual Studio or in VS Code or something, and then you edit your things. And by the way, this select an account is always asking me for, you know, whenever I need to push something and fetch, and it gets annoying. So, because it will pop up next time it wants to fetch, fork needs to fetch, it's going to ask me again, and I don't know why. It is a little bit annoying. Anyway, let's go back here. So we have the sky function. That's the only thing, because this is not a vertex or a fragment shader, right? This is just a special sky shader, and I really like that they have a special type for it. And unlike in Unity, where you just use like basically a fragment shader, and then, you know, because sky shaders are unique because they have different inputs and they have only one output. The output is color. So if you just make the color into it is a vec3, so we can just say 111, right? This is going to be white, and if we save that, there it is. And now everything is white. We can barely see anything. Everything is super lit. And yeah, if I make this into a 0, into a red, it will be red. And I actually don't even need to save, because this will save automatically. It will. It's actually pretty neat. I like this. This is one of the bright things about Godot. Okay, so now that we have done that, how are we gonna make a planet? Well, I can get. Okay, let me first get my coffee, because I put the water to boil, and then I'll be back. Okay, sorry for that. Okay, so I just remembered that there was this trend on Twitter a few days ago, which was like, share something red. Here's my red. Share something red. Maybe I can. Why is this not red? I think it's because it has its own. Does it have? Oh, whoops! I accidentally put Q. I accidentally put. There is actually. I think there is a reflection. Oh, come on! Why are you mixing? Okay, I think that in the cupola there is a reflection. Yeah, there is. Okay, so let me just disable the reflection probe. Okay, now it's red as well. I can share this as share something red for entry. There we go. Share something red. Okay. Let's take another one. So yeah, this is how you make your sky, right? Everything is now red. It feels like it's overheating. Wait, did I just remake Iron Lung? Maybe I did. Anyway, so how are we gonna make a planet? Well, first we need a sphere, right? We need to have some kind of a sphere that is suspended in our blackness. So, sky actually has a few things. Godot sky, let's see. Sky shaders. Yes, there it is. There's the documentation. So let's look what is actually available to us. There's actually a way also to flip between the cube map pass and not, which is cube map pass is basically the one that shades. It basically applies the ambient, and then not cube map pass is the one that is your sky. So basically you can what you can do is you can put an if cube map pass and then do this color, else do some other color. So let's see what happens. Yeah, as you can see, it has already changed, and yeah, there you go. This is also interesting, but this is just me showing that this color, this cube map pass happens during the. This actually looks really nice. Why is it? Okay, I don't like that. It is mixing. It doesn't work. Okay, so yeah. Oh, I can actually code like this as well, which is nice. Yeah, so basically this will run in the ambient. Yeah, only, as you can see, it applies the red, and then this is the actual background. But we're not actually going to do this. We are actually gonna just work on a single one. I was just demonstrating that this is what it does, right? Because, for example, you might want to do some kind of a simplified calculations, as it says, expensive sky calculations. You can just replace it. Okay, and yeah, there is also like half res, doing something different. But yeah, here are all our globals. We have time, we have position, camera position, and most important, there it is. It has appeared again. I'm just gonna hide it. There is pi, which we're definitely gonna need later, I think. Radiance, what is a radiance? Radiance cube map can only be read from during background pass. Check not at cube map pass. Interesting. Interesting. Radiance. Okay. Maybe this is part of the GI. I don't know. So E constant, but the most important thing that we're going to need is the I direction. So this is the direction of where we're looking at. It's the ray going out. So if I make the color equal the I, what's the name of it? IDear. Okay. There we go. We can see the direction. This is a vector, right? So there's black and red, and there's purple in the other direction. So it's like redness is the X and greenness is the Y. And then as they combine, they actually, yeah, there's a Z as well. Forgot about that. But yeah, there it is. There's also the blue, and I love the ambient color of this one. And look, you can even now actually what you can see is the global normal. of every, because of the how it reflects, right, light. Interesting. This is like a weird way to do output a global normal. Okay, so can we define a sphere? Whoops. How can we define a sphere to get something like this? Well, for the beginning, let's try by just getting a... Let's see what happens if we just do like a length. A length of idea. Well, everything is going to be black, right? And it's not even correct. Oh, because it needs to be a vector, yes. So I'm just going to cast it into vec3. And there it is. Everything is white. But I'm actually going to output, I'm going to offset it by some number. Let's see what happens now. Okay, well, nothing happened except that it got a little bit blue. Let's see if I can actually... yeah, I can't do that. Why am I even doing this? Length of idea plus a vector. Yeah, one thing that is going to be very useful for us is that we can output some uniforms, and so that we can actually test it in, so that I don't do this in shader editor all the time. We can add, so yeah, let me actually explain. Let's go into, what's the name of that? Excalidraw, there it is. Okay, oh wow, this is super old. What was this? This was the quad tree I was explaining. Was I explaining myself? Maybe I was explaining myself how to do a quad tree. Okay, well, first off, let's go into dark mode. Second, let's... I'm gonna save this just so that I have some nice... okay, and let's actually clear it. Reset the canvas, confirm. Yeah, so what do we have here? Well, we have us, we're here, right? We have our camera is looking somewhere. And in world space, we have our planet somewhere close, right? And what is this planet but a sphere with some kind of a center? So this center is actually offset from our camera, right? And what we actually need to find out is we need to find the rim of this sphere. And how do we do that? How do we find a rim of that sphere? Well, we can do that by looking for some simple ray and sphere intersections, right? Because what we actually have here is that we have a camera that is casting rays in all directions, right? It's actually looking at all directions, and this is what we have here in our, well, if I output just the idea, if I only output the idea, this is what we have. We have this vector map. Okay, what actually happens if we do a dot of idea and some direction, right? We can do like nothing happens. We don't even have... Oh, well, this needs to be a vec3. I forget that Godot doesn't automatically cast. Okay, there it is. Look at that. We have something. We have a plane. And we get something that is very similar. Okay, let's flip it around. Let's do a minus instead. Okay, there we have recreated the classic just on the bottom, just ground plane. And what we can do now is we can actually just kind of sharpen this. What is interesting is also that we can notice that the grid disappears if we look up. And that is because, yeah, well, I'll explain later, I guess. Okay, so yeah, if I just want to make this like bigger, if I want to push this down, I can just I can just multiply with some number, right? Let's see what happens. Oh, this is, yeah, in Godot, you have to make it, oh, look at that, beautiful. Look at that beautiful bloom in Godot. Nice. Okay, well, this is not actually correct. What if I do a -5, perhaps? I don't know what I'm doing. Okay, I'm just getting the same thing. I could, okay, what if I just offset it like this? No. Does it do anything? Whoa, nice. Okay, I'm kind of just shooting in the dark with this. I'm not actually trying to do anything, just kind of mess with the shaders. This is cool thing about shaders in general, that you can just mess with them and get something. And why is this happening? I think this might be like this might be a division by 0 happening in this line or something. Could there be? It is likely. Actually, no. There is in dot products. There is no divisions. It's just multiplication. I don't know exactly what is going on there, but definitely something funny. Why in this exact line? But I think that probably I need to saturate this, or well, basically I need to clamp. I need to clamp the dot. Let's put it here. Clamp. You're gonna clamp this to this -1. Oh, 0 to 1. Is this going to work? Yes. So yeah, this solves our problem. It's because the dot gets lower than lower than 1. Yeah, it's basically not normalized, and yeah, this should also be normalized. All right. So yeah, this is actually how you can do like how you can do sun. So if we want to show the sun somewhere in the distance, what we can do is we can do something like this. Wait. No. Let's multiply the dot. Huh, interesting. Nothing happens. Wait, did I mess something up? What did I do here? Okay, this works, but then I multiply the dot. Oh, I hate this. Godot wants a float. I keep forgetting that it actually doesn't work because I'm giving it as a float. I keep giving it an integer. Okay, so yeah, there it is. And by the way, I keep pressing save, but save actually does nothing. I think that if you want to save a file, does .0 work? .5. Okay, so dots work. Okay, so yeah. I am clamping here, but I am actually going to also round this, so to get a nice line. Come on, where is it? Okay, maybe try 1. Oh, again, I made a mistake. Okay, look at that. We have the planet. We have the planet. Okay, well, is this the planet? I don't know. What if we offset by something? Oh, look at that. It actually works. Okay. So yeah, well, this is my direction. But let's add here a uniform, and I'm gonna say uniform float. Well, no, let's do a. Let's just call it A. And let's see. Okay, now I can add A somewhere. I can say A plus, and let's see what happens. Let's see what happens if I change it. Okay, where is the rest of my, oh, I need to click here. Okay. So if I select my shader, where is it? No, it's actually my environment. It is selected the environment, and my shader material, and shader parameters. There it is. It appears, and now I can change the A, and voila, I get some some radius. But yeah, you can see that we have created a ball, but it's only below us. And this is not actually the real ball, because yeah, if we go inside a ball, we get submerged into the ball. This is just a dot product, right? This is just a simple dot product. But I just wanted to start with this because it kind of looks like Earth. But actually, what we need to do is we need to do some proper sphere, ray and sphere intersection. So for the beginning, of course, as I said today, better background with this custom Earth shader. I'm gonna start, as I said, a simple sphere, well, not really a sphere, with a dot product. And next on, we're gonna do some ray and sphere intersection. So how do we do ray sphere intersections? Well, as I showed, we have a center of the sphere, we have our position, and we have the offset. So I'm going to introduce a new variable. I'm going to introduce a uniform, which is going to be my my Earth. Let's call it Earth center. No, let's call it planet center. Okay, so that's going to be my offset of the planet. And let's actually kill A, because we don't need A anymore. And I'm going to completely kill everything. Let's actually just put a, instead of A, I'm going to put here some, what was it, 0.5? Something like that. No, it was -0.5. Something like this, but less. Okay, we have our Earth. Well, we can actually do this with a light. Let me actually try this quickly. We have light direction somewhere, right? Light 0 direction. Hopefully this light direction is the sun. So if I just plug this in, do we actually see the light? Oh, look at that. We actually get our light for free. This is now the sun, not the planet. Yeah, and there is the sun. You can see that this is the direction of the sun. And now if you rotate it, look at that. It's actually rotating. The sun is rotating. Nice. But yeah, I can actually make the kind of the disk much smaller. So yeah, we can actually reuse this for a sun disk. And this, well, it should be less than -0.5, right? I think that if I offset by, yeah, then it totally disappears. So it needs to be like -0.49, something like that, 9. There we go. And we have our nice sun sphere. Cool. So for the beginning, let's just have a sun that moves around. We have the sun in the sky. We have a very simple ball. Okay, but let's actually convert this into some real measurements, something that gives me an offset. So let's search for ray sphere intersection. And well, I actually, of course, Googled this before, as you can see. We have 2 articles that explain a little bit of ray sphere intersections, how it works, and when do we have to say when we return. But yeah, basically, let me find. Yeah, this is what I'm talking about. So what are the possible modes of intersections, right? You have an intersection where your ray hits the sphere, it goes through the sphere, and there's 2 points. There's the entry point and the exit point. Then there is a point where it is kind of glancing, tangentially touching the sphere, and of course, which is equal, but this is very rare in real maths, right? It's almost never going to happen. And we basically have no intersection. Those are the 3 modes, right? Like the ray is completely missing the sphere. And now for basically what we need to find out is we need to find out this point, which is called T0, and this exit point, which is T1. And we actually really need this T0 because we need to find first where our sphere is, how distant from our camera it is. And here it tells us how to actually compute the intersection point from the center of the sphere. And then when we have this point, it is very easy to calculate the normal and the exact point of hit. And well, how does that work? Well, we can actually see that there is a geometric solution. This one is probably implemented in C++ and it has references. Okay, so basically we need this, and then we get the T0 and T1, and this also early outs if it has intersected. So basically this function returns true when you have intersected, but it actually early outs if you're not. So let me actually just make a new function. Okay, I'm gonna make a new function. I'm gonna call the same one as they did. What is it? Intersect, but I'm definitely going to need the center as well. So yeah, let's do bool intersect, and I'm gonna have a ray, but I'm not gonna pass it a ray. I'm going to pass it the origin. So this is going to be vec3 origin, vec3, the ray has origin and it has direction, right? Let's call it dir. And then we have the center of the sphere, and we have radius of the sphere, of course. And then we are going to actually out these two T0s and T1s because that is important for our later calculations. So I'm going to do a out float T0, out float T1, right? And for this one, I'm going to actually, I'm going to copy the whole thing, geometric solution. And we have here some weird types. I'm going to use vec3 instead. We have L, which is the difference between the center and the origin. Well, it's called orig, but yeah, let's call it orig, I guess. And then we have the center T, which is the dot product. Well, in Godot, it's going to be dot. I don't know if you can actually see the text. Maybe I should. Can I resize this text? There is no text scaling or something in here. Oh, there it is. Okay, you can actually control and scroll. That's good. Okay, cool. Hello. I am a tray. These minis leave just followed. Okay. I don't understand. Text is quite okay visible. Good to know. All right. So yeah. By the way, let's. Where my son disappeared. Okay, doesn't matter. Okay. So we have the intersection. And of course, this is going to be the dot between L and direction. Did I also call it dir? I did. Okay. And well, why is this commented out? I don't know. Okay, we'll see later. And then we have the square product, the square D2, which is the oh yes, this is something that confused me a long time ago when I tried to implement this kind of a shader before, because like dot product of L dot L, but it's basically like a square length. That's what it is, right? And yeah, dot of the 2, and then we have that, and this is going to be, why is there radius 2? Oh, am I passing a squared radius? Maybe. So let's just do a radius by radius. Yeah, because this is also a square, so this needs to be a square as well. And then we finally have square root. That works, but why does it say, oh yeah, because this one, okay. Let's just do radius 2 here. Okay, there we go, radius 2, and then we have that, and then we have T0 and T1, and finally we have to return true at the end. Let's see if that has compiled. It has compiled. Okay, so let's try to intersect, and I'm going to call this, yeah, let's just do if intersect, and let's go with a super simple so we have the origin. The origin is the center. It's my camera, actually. So it's gonna be vec3 0. I can optimize later by removing all these parameters if this is possible. The direction is going to be my I direction. That's the direction of the ray, and then we have the center, which is my, how did I call it? The offset, planet offset something, planet center. Yeah, that's how I call it. And then we have the radius. The radius, let's make it 1 for the beginning. And finally, we have T0 and T1. And can you do this in Godot? I don't think so. If, okay, yeah, I think that you can't do it like this. T0, T1, okay, without this. Does this work? No? Is it just T0 and T1? Okay, that compiled. So I guess it's just T0 and T1. It's not clear if it's out or out. If it's out or not out. Okay, so let's just output, if we have intersected, let's make it a, like, output white. Boom! Boom, because we're inside, hopefully we're inside the sphere. I hope it's not something else. Okay, let's see. Where is my, wait, oh yeah, I opened the, and there it is. Sky, shader, and yeah, planet center. Let's move it somewhere. Let's move it. Oh, look at that. Look at that. We have our sphere. It actually works. Oh, we have 2 spheres. We have 2 spheres. Okay, I think the reason why we have 2 spheres, oh yeah, they also rotate. I think the reason we have 2 spheres is because we have commented this out. Is that the case? No. If TCA is less than 0.0. Yes, that's the case. Yeah, I don't know why they actually commented this out. Maybe because T0 is already, like, I don't know. Well, we'll see. So yeah, there we go. We have the sphere intersection, and now we have actual planets, except it's just like a sun. It's nice that it actually combines with our old sun, which is, where is it? It disappeared. There it is, actually. So they're actually combining because it's just an if. There, we have an eclipse. Nice, cool. And as we can see, this is actually completely reflecting on the model, and it looks really, really nice. Okay, so let's see what happens if I just output now. Let's see what happens if we have the T0 and T1, right? We know what the entry point and the exit points are. So let's output T0. What happens here? Well, nothing has happened. Let's make it a little closer. Maybe something is going to change. Oh, there it is. Look at that. We have a little bit of darkening in the middle, and maybe we can implement some atmosphere like this, you know. But what do we do now? Well, I want to have the sphere have a little earth texture, right? Let's not keep it just like a white bulb. So yeah, as I said, ray and sphere intersection works. And I also did this. So now the next task is add a texture, add an earth texture, and show it on sphere, right? Well, what do we do for that? Well, here is the thing. We actually know the position on the sphere. And how do we know? Well, we know it because of this. We have, oh yeah, one more thing. Let's add also a normal. Get position and normal. That's actually going to be the first thing that I want to do. So, as we said here, we have somewhere the formula of the point. There it is, computing the normal and the intersection point. Yeah, so we know where the point is because the p hit is this. It's ray plus dir by t, and the t is actually, in this case, it's t0. So I'm just going to actually calculate that. So let's call it vec3 hit point, and instead of p hit, such an ugly name, fit. Okay, so we have the origin, right? The origin is vector 3, 0. Well, in my case. And we have the idea, and then we have by t0, right? And that's the hit point. Let's output the hit point. What is it going to give me? Well, it's not actually, it doesn't need to be vec3 anymore. There it is. Look at that. We have some nice colors. But of course, this is just the position. Let's see how that reflects. Interesting. Oh yeah, because it has the sun as well. Let's see the eclipse now. Oh, there it is. We have the sun as well. Nice. Okay, so yeah, as we can see, this is actually the position, because once it goes below 0, y0, it turns black here in this region. So yeah, we can see that this is our position, which is perfect. We're going to need this position later. But I also want to get a normal, and the normal is going to be, what is the normal? Well, if I need to explain that, the normal is basically, yeah, so what we got here is the position, which is relative to, so the position is actually relative to our, to our camera. If you take that this is, we have, oh wow, this is so slow. I don't know why. Okay, this is like the reference point. Then this position will be some point on this grid. That's the position that we got. But the normal is the direction from the center towards the edge. So this is basically the normal, and we can get that through this formula. Normalize hit minus, yeah, of course, it's very easy because it's just a hit. It's just the difference between the hit point and the center. So vec3 hit normal, let's call it like that, and that's going to be normalize hit point minus planet center. And let's actually output this hit normal as well. And here we go. There we go. Now this is an actual normal. And if we look below, right, we're gonna see that this is this quadrant is completely black because it is below 0. And this behind quadrant, right, now it is actually consistent with our with the position of the planet, right? This is, you can imagine it as being like, as this is the texture of the planet. This is how it looks like. This is like, there is a red, there's purple, there's blue, and now it is actually consistent with the surface. Okay, but how do we, now that we have these normal coordinates, how do we make a texture that actually outputs there? Well, first let's add some kind of a texture. I'm gonna call it, that's gonna be a sampler. It's gonna be a sampler, and it's going to be my planet. Well, let's call it ground texture. And this ground texture is going to be, yeah, let's let's actually get some earth texture from the internet. Earth texture, just to test it. Solar system textures. I'm pretty sure these are like open source, but okay, let's just for the beginning. Okay, this is way too big. Is there something that is smaller? Just for testing. I just want something smaller for testing. These are all 8K textures. There is something smaller. Okay. Like, I'm afraid to use 8K textures. Okay, well, should I use an 8K texture? So much detail, so many pixels. Look at that. Okay, let's actually use a 8K texture, even if this is how do you call it? If this is like a PS1 style game. Okay, art, and I'm gonna put here. Let's put it in like Earth. In a special folder. It deserves the special folder. Okay, 8K day map. And now when we load it, is it gonna take forever loading? Scale down. Yeah, I can always scale down. But I don't know if actually this supports, if Godot supports scaling down or not. In editor, because Unity does. Like in Unity you can actually select how much do you want it to export. Okay, so we have the Earth. Let's load it. It doesn't want to be loaded. What is going on? It says broken. Yeah, I knew it that using an 8K texture is probably a bad idea. There it is. Let's see. Okay, can I double click? I can't even double click on it. This object is read-only. Yeah, you can't actually. Okay, let's see. Once it loads, it should be fast, right? Even if it's... Okay, let's do that. There it is. Oh my god, re-importing. Why are you re-importing now? Okay, there we go. We've added the ground texture. Yeah, so let's actually just put some, oh yeah, I did actually do get position and normal. So texture, sampler, you pick a sampler. Yeah, I'm gonna ground texture, and UV, I don't know, let's just take, does it have UV like this? This is gonna be UV3 hopefully. Let's ground text, ground color, something like that. Let's just call it ground, and probably RGB, and then I can do ground. No, that doesn't work. Okay, what about XY? There it is. Oh, nice. There we have our planet. But as we can see, this is just, wow, this actually surprisingly works well. But it's completely screwed up. And that is because we need to actually project this onto a rectangle. Like, this is fun. This is fun. It actually looks good. Actually, it looks pretty good. But yeah, we actually do want to not have it project just onto like 3D coordinates, right? Because this is what is happening here. It is simply projecting onto the like planar projection, because we can see that on the bottom it gets stretched out. There it is. You can see this. So what we actually need to do is to be able to wrap around our texture, because we have to deal with projections now, right? We have a projection, and we have a 2D texture, right? And we want to wrap it around a sphere. So there is there's a total side of science dealing with projection and maps. But in our case, we want to basically take this, right? We want to take these points, put them on the top, this and this one also on the top, and then wrap everything around. So basically, like, project this line like this, right? And this line is going to be on the other side. So if this is the grid of our texture, right? This is going to be our future grid here. It's going to go around. It's going to go around. It's going to go around. Well, and how do we do this? Well, there is a formula for that as well. And it is called, let me remember, something like rectilinear projection. No, is it rectilinear? Sphere projections, rectilinear projection. Is that it? Okay. Or is it rectangular? I think it is. I think it is rectilinear projection. Sphere, and then we say algorithm. That's how you look for things. No, not algorithm. Let's search for shader. Projection sphere. Equirectangular to rectilinear projection. 3JS. Oh, this is in 3JS. Maybe it is equirectangular projection, not the rectilinear. Is it equirectangular? Yeah, it is. Shader. Godot. Maybe it's gonna give me Godot perspective projection. Screen space equirectangular. Godot, the purpose undistort. Equirectangular. Is it this one? I hope so. I definitely found somewhere this code. Using a viewport as a... Okay, let me see. The shader code about retiners and equirectangular projection. Ah, here we go. Here we go. Texture panorama. We have some shader code that returns us what? A sampler. You pass it a sampler. There's definitely a way to... what is the name of it? Projection, equirectangular. Godot, perspective projection shaders. Cylindrical. Equirectangular. Okay. But why is it even using screen UV? I don't need a screen UV. Towards pixel. Okay. Let's see. spherical coordinate. Cartesian to spherical coordinate. Okay, well, we have some shader. There definitely is something out there. How to get UV for sphere. Where sphere surface point. Okay, let's try this. Leaving here for myself. Oh, look at that. Look at that. Sphere map. Sphere to map equirectangular. Okay, let's try this one. Let's try this. Okay, we're gonna have... Did I just call this interact? Intersect. Wow, and it totally worked until now. Okay, let's go with this, and I'm just gonna rename it to vec2, vec3, vec2, and that's it. No, what is the problem? This is the problem. And anything else? Let's put a 0 here. 0, 0. Any other problems? What does it say? Atom 2, too many arguments. Expected, okay, maybe it's because it's a wrong formula. Ah, there it is. It is actually 810, not 8 and 2. I don't think 8 and 2 exists. No, it doesn't. Not in Godot. 8 and 2 is HLSL or something. Yeah, let's try to apply this formula to create sphere to map. Terrible name, but anyway, let's see. Ground texture, so we're gonna turn the hit normal into this, and we're gonna call it as a function. Let's see if, oh, I forgot one bracket. Is that it? Looks like it. Looks like it. Oh my god. Does it work? It looks like it works. Well, it doesn't work when you're inside though, but it does work like this. And why is that actually so bright? It's kind of a, okay, let's go to the sea. There it is. I need to rotate it a bit as well. Nice, we have Antarctica. Okay, let's go somewhere. Let's go somewhere in Europe. Yeah, I know that I'm biased. What can I do? Oh, it's actually upside down. It's actually upside down, but look, it actually works. We made an earth texture. Nice. Okay, so far so good. It's only 1 hour and a little minutes to get me to the Earth. Okay, so that's how. I just taught you how to Google the right things. Okay, so what is going on here? Why is it so bright? I don't understand it. This is definitely not it. This texture looks a lot less bright. Oh, it is maybe because I have exposure, rotation. Oh, you can actually rotate the whole skybox. Nice. This is actually going to be useful, but not really, because we have the sky. So this is rotating everything. Yeah, that's actually not good. Energy multiplier. Okay, well, I can reduce the energy multiplier. Is that actually scaling the ambient as well? Yeah, it is. It is actually scaling the ambient. Maybe I have some exposure set up somewhere. Reflected light. Am I increasing exposure somewhere? SSAO. Glow. Maybe it's glow. Oh, yeah, the glow adds a little bit, but not much. Adjustments. I don't have any adjustments. I don't know. There's definitely a little bit of exposure being added. Okay, well, it's better with this thing. Okay. Well, let me flip it around. So let me save this as a vec2 UV. And Y is, let's flip it around. Okay, and I'm gonna put this here. Okay. Are we good? No, I think it's rotated again. So I actually need to flip the whole thing. Do I need to flip the whole thing? Minus ground UV. Oh yeah, there it is. Okay, I just had to flip the whole thing. Let's see. Where is my shader again? This nesting of things is a bit annoying. I always need to open stuff. Okay. Custom FOV. Oh, you can actually put a custom FOV for your background. Okay, well, I don't want to do that. I'm gonna use the FOV of the camera. So yeah, let's. It looks a bit stretched to me. Oh, something blew up. I think it's my my washing machine. It definitely looks a bit wide. Maybe it's a wrong projection type. Maybe it's not equirectangular, but the other one. Maybe it's equal area. Let's try that. Vec2, Vec3, Vec2, A10, point. Is that it? Yes, it is it. Okay, let's try to use the other one. Equal area. Yeah, I think it's actually this one. It's the equal area map. Good. Good. Okay. Is that it? Let's see. Yeah, I think that Europe looks more natural now. Look at that. And you know what? Since this is a you know, a PS1 style game, let's make it pixelated, since everything else is pixelated. Okay, how do you do sampling, Godot sampling in shader? Filtering in shaders. You add like you inherit a nearest on a sampler, I guess. Let's try that. Ground texture. It's strange that it uses this. Yeah, there it is. Oh my god, nice. Well, it's not actually. It has some weird compression artifacts here. I wish I could use a better compression. But here we go. Okay, here I'm somewhere there. Cool. Look at that. Look at that. We have a nice sphere. And then, so here's the cool thing. If I actually put some reflective ball, I should be able to see the sun reflected. Well, actually, inside, if I look at my iron, yeah, you can actually see the planet because, well, the planet is not occluded. Okay. Yeah, it is funny. It is funny to see it. Oh, and maybe it also reflects from the glass. Does it reflect? I don't see it reflecting in the glass. Does the glass reflect the skybox? I hope so. That looks cool. Okay. Well, there we go. We have the planet. Job done. Well, you may notice that the world doesn't look like this in real life, right? Because it's completely lacking the atmosphere. So, next up. Done this. Next up, adding atmosphere. Oh, and by the way, before we do atmosphere, I could do some shading. So let's actually make it, we have the direction of the sun already, right? So let's add the night side. Well, how does lighting work in shaders? Well, it's very simple. For a very simple, well, I am just going to do a very, of course, it's a huge topic, but the simplest form of lighting is called Lambertian, or Lambertian. I don't know what exactly how you pronounce it, but it's basically just normal dot product L, which is n dot L. L is light. So the normal of a surface and dot product of light, and that is going to be basically your light intensity. Since we have both, right, we can actually calculate light. We can say float light, and we can say dot product of hit normal n, and we have the light. Light is light 0 direction. Okay, there we go. We have the light now, and we can just multiply that with our light. Ta-da! There we have our shading, our planetary shading. That's it. And yeah, it's simple as that. And the cool thing is that now we can take the sun, we can rotate it, and there we go. We have correct lighting of our planets. Nice. Okay. All implemented in a single shader. And this is also going to be reflected on the station. Okay, so now that we have that, now that we have shading, what I'm going to do now is I'm gonna make, oh yeah, and by the way, since dot is minus, sometimes there is a weird, okay, let's me show you something weird about this, okay? If I start increasing multiplication level, you will notice that the grid here starts disappearing, like the grid from the helper grid from the gizmos, right? It's like it's disappearing in the shadows. And I was thinking, what the hell is this? And this is actually because simply I'm not saturating, I'm not clamping to 0. So because this is like minus 10 now, right? Or minus 5, because this is multiplied by 5. So you should always clamp your values, especially for light, between 0 and 1. And there it is. There we go. Now we have sharp light and sharp darkness. And yeah, we can actually, we can actually now multiply this to increase this kind of a band, the band of light. So if I just multiply it by 2, it's going to be brighter. And at some point, this line is going to shrink lower and lower. So we can manipulate the night line sort of by just multiplying the whole thing. And then since it's clamped, it never goes above 1, and this never goes below 0. So there you go. We have some little yeah, let's go like multiplied by 4, something like that. Okay, so cool. We have our Earth, but let's add some atmosphere. Well, what is atmosphere? What is atmosphere but just a, we have our Earth, beautiful, beautiful sphere. Actually, I could use a sphere since the sphere exists. Okay, yeah, let's do the sphere instead. What is atmosphere but just another sphere on top, right? That's it. That's the atmosphere. So I can just repeat the whole thing, and I can just repeat the whole thing, the intersection, because now we have our camera over here. We have our guy looking at planet. It intersects, but it also intersects with the atmosphere. And so here's the thing. There's actually, at this point, we're intersecting both. But if we look through here, right, what we're actually doing is we're only intersecting the atmosphere and not the planet. So if you remember, we've only used, in the planet, we've only used this point, which is the T1. Sorry, T0, as it's called there. Oh, T0. But now we're actually going to use the T1 as well. Yeah, so we have this thing where we have a T1 as well. So let's do another sphere. Let me fork this at least. Okay, whoops, I'm not gonna, okay, let's not submit the Earth texture for now. I'm gonna commit it later. Okay, so ground texture. Is this LS? I didn't add it. Yeah, this is the problem because I didn't add it to LFS. JPEGs are not added. Okay, let's do that later. Why does it have this white border though? I don't know. Earth skybox with Earth texture with no atmosphere. Let's call it like that. Okay, cool. So let's do another intersection. I'm gonna do afterwards, and I'm gonna do the vec3 0 because that's the ray origin. And again, we have the I direction, we have the planet center, everything is the same, except now the radius is slightly different. And yeah, we can actually fill up the same T0 and T1, why not? So yeah, now that we have that, we can do, let's just add a little bit for the beginning. Can I actually read it like this? Let's add a little bit of color. There it is. Look at that. Our beautiful atmosphere. That's it. Job done. Okay, so yeah, as you can see, we have another sphere now, and the color is being added on top. Yeah, so what we have here is we have a very simple sphere intersection. But yeah, let's actually try to, you remember in the beginning, I actually used this T0. I used this T0 to find like basically the direction to the center. So let's see what happens if I just use the T0 instead. We have a little bit of a fall off. So let's make it, let's increase it by 4 or something, but I need to saturate it again. I need to clamp to, I don't like that GLSL and Godot don't have saturate. That's a handy formula. You need to always do a 0 and 1. Whoops. What is going on? Okay, yeah. Let me actually do let's see what happens if I do a cubic. Aha, there we have much bigger fall off. So yeah, if I just replace it with this, right? Let's only see the atmosphere. We can see now there is this fall off, and yeah, it increases. The fall off curve increases if I just square it. Basically, if I just multiply it twice. Let's see what happens if I cubicize it. There it is. Nice. Okay, so what we can do is actually we can just do this, and we have the atmosphere. Ta-da! Nice, but let's actually make it closer to the ground. Okay, look at that. Look at that. Maybe something like this. Okay, but of course, this actually makes it look like it is the atmosphere is like a glass bowl. So yeah, what is going on? When you have this ground, and this is the limit of the atmosphere, right? Well, let's say. Right now, what I'm actually doing is I have this I have a peak. If you imagine it if you imagine it as a graph, I have a peak that goes down like this, right? So it's like it starts from 1 and it goes down to 0. What I actually want to do is I want to make it bright at the top. Yeah, I want to make it, well, yeah, this is, what am I doing here? Okay, well, if I say that this is the height, right? If x is the height, then it shouldn't go, the graph shouldn't go up, right? But the density should actually go from up to 0, or well, not, yeah, it should go to 0, but it should go more like this, right? Because it's just kind of quadratically falling off. So what we have here is T0 is basically, I think that T0 is 1 at the edge. I'm not actually sure. Oh, it should be color is T0. I think it is. And this is, and at the bottom it's somewhere some other thing. Let's try to let's try to do something like this. Okay. No, I actually want to floor it. I want to floor it. So there's going to be like one line. And if I floor it plus something minuscule. Okay. Okay, so it's not exactly 1. That's my mistake. Let's see, where is my environment? It's not exactly 1. Yeah, it actually changes. It actually changes. So you can't we can't rely on that. But here is what is actually consistent. Yeah, we can actually get a normal of a view direction. We can get a dot between the I direction and the normal of this planet. And that is going to be consistent. So that's the thing that is going to be always 1. We can do it like that. There's another thing that we can do. We can do it through density. So how do we figure out the density of the planet? Well, okay, let me draw on the same map. If we have a camera here, we're casting a ray through here, and we have this is our T0, right? This is our T0. Oh yeah, you know, I just realized that how stupid I am. T0 is actually just a distance along the ray of the, yeah, that's what T0 is. It's just this the distance between me, right, and the ground point. That is why it's actually lower on the bottom and higher on the edge. So it has nothing to do with, it's, you know, that's why you can't rely on it, because this point can be either far away or close. So we shouldn't rely on that, right? Instead, there is one thing that we can do. We can calculate the difference between the atmosphere T0 and the Earth T0, and that's how we get like the density of the atmosphere, kind of. So near the edge, right? The more, the higher the angle, or is it the lower the angle? Well, I mean the higher the angle between the the center, then we are going to have deeper atmosphere, right? We're gonna have something like this, right? This is gonna be our atmosphere. Yeah, so let's try to calculate that. We need to propagate T0 on the outside. Let's call it PT0. That's going to be the planet T0. PT0, PT1. And we're going to have the AT0 and the AT1, which is like atmosphere 0 and atmosphere 0.1. Okay, so PT0, well, AT1 minus PT, no, this is going to be 0. AT0 minus PT, that's the depth of my density. That's going to be the length of the atmosphere, basically. So what we can do is, let's try to add that value, plus equal density. Okay, let's see what happens now. Instead of replacing it, nothing happens. Where is my Earth? Where did my Earth disappear? Unknown identifier T0. Okay, where am I using T0? T0. Oh, there it is. Okay, so let's use PT0 instead. And there it is. We have, interesting. Why is it actually gets darker over there? Strange. PT0. Well, PT0 actually is not. Oh, interesting. Well, this is actually not initialized. What if I put it to 0? Oh, it should be 0.0. Okay, interesting. Still doesn't make any sense. So this is AT0. This is PT0 for sure. Okay, let's increase the size of it. I'm not modifying PT0, right? No. Okay, well, let's also clamp this 0 to 1. So that we don't have the weird... Okay. Interesting. Yeah, let's actually increase the density so that we can see something. Oh, again. Floats. Hello, T0 is PT0. What? I don't know what you're talking about. No, I said that much earlier. Oh, okay, that was much earlier. I don't know what is going on there. This is weird. I don't know what is going on in this hole. There's something. Ah, okay. This has to do with the light. Something with light. Must be. Must be something with the light. It's getting multiplied. Ah, yeah. There's a hole from the light. Okay, yeah, it's because it's actually getting multiplied. Okay, let's not do... Okay, let's actually focus on the lit part. I'm gonna do lighting later, okay? Let's for now make it just... Let's just make it 1. Float. Light is 1. 0.0. And still we have this weird... Okay, so who is adding... What the hell? Oh no, okay, now light is not the culprit, something else is the culprit. So yeah, well, the thing is that I don't care about that. What I care about is the rim. Let's increase this density to 50. Okay, well, the problem is that... you know what? Let's do a special case. Let's turn this into a bool. Planet intersected planet. Okay, let's move that to here. And now I can do if intersected planet. Okay, so now I'm just going to apply this if intersected planet. All right, and it seems to be... you know what? Let's put this inside. Oh! It should be PT0 minus. This is... Okay, there you are. There you go. Yeah, of course, because it's the planet. Planet is the longer than atmosphere. I was thinking, I flipped around my thoughts. Okay, so there we go. We have some density relevant coding. Okay, well, now let's also make it work for when it's not intersected. And I can do this by actually calculating density when intersected. So yeah, let's do like the ternary. Like if intersected planet do this, but if not, I'm gonna do atmosphere 1 minus atmosphere 0. And then we don't have to do this. We can just do color. Oh, look at that. And you know what? By default, what we got is we got this little fall off on the edge. Why? Because this is like, you know, if we have a ray that only touches a little bit, right? We're gonna have 2 points along the sphere edge. So and then we have the next ray that only touches this point. That's gonna be much smaller than this one. So we have this like fall off automatically. Nice. Okay, and now if we put it something close to the planet, look at that. It looks realistic. Okay, let's see what happens if I push. What happened now? What happened? I undoed something. Okay, there it is. Let's put the planet a little closer. Let's put a little closer. Okay, there we go. We have the atmosphere. But here's the problem. Right now, well, here's one thing. One thing is that the atmosphere is not white. It's a little bit blue. So let's actually multiply this with blue. Red, green, blue by this. Look at that. Suddenly it's blue. It's awful blue. Okay, let's raise everything else up a bit. Does it work? A little bit purplish. Yes, magenta sky. Okay, well, it should probably be a little bit green. So let's red more green. Something like this. Something like this, even more cyanish. There it is. We have something. We have something that looks like atmosphere. This is almost correct now. Almost. Ooh, much better. Much better. Much better. Okay, let's not click like this. Let's export the. Let's make a uniform. Can you do a color? How do I do export uniform color? Atmosphere color. Can you do Godot uniform color? Hi, how long have you been working in Godot? 2 weeks. No, 3 weeks. I don't know. But you know, the knowledge transfers from one side to the other. What is color? Is there a color? Is there color? Some color. Vertex built-ins. Okay, can I use a uniform color? I wanted just to show in the inspector as color. Changing a specific sprite, shading language. Okay, well, I guess it's in this page. It's just somewhere hidden completely. Let's go to uniforms. Uniforms. Okay, float some value, color. Oh, hint color. It's actually that. So it's actually a vec3, but I put a hint color. No? Does that work? No. Is it just color? Source color. There it is, source color. Okay, so maybe this is the difference between old Godot and new Godot. Okay, so let's put it some weird color so that I can use this. Atmosphere color. Let's put that. Yeah, let's multiply that. Oh, actually, can I initialize it to this? I wonder. Do you initialize like this? Yeah, I guess. Yeah, there it is. Nice. Okay, and then I'm gonna atmosphere color like this. It was not that exact one, but doesn't matter. Okay, so cool. I can actually change. I can change my atmosphere color. Outside. Hey, not bad. Not bad. There we go. Something like this. A little bit bluer. I don't know. But yeah, here is our problem right now. Our problem is that in this case, right, where we're actually just using the what is it? Where is Excalibur? There it is. Yeah, what we're doing is we're actually just taking the density of, the density is actually just our distance from one side to the other, which means that our atmosphere is completely has equal density, right? So it's like if we take this graph of height, right? It's actually as if the density was just like this. So we actually want to turn this into a falling off density, and that is why our atmosphere looks weird like this. So Doc is older version. Yeah, I guess so. Yeah, you need to make sure that when you're, yeah, 3.0, when you're here, you need to go to like latest version. I don't know, 4. Let's try 4.2. Shading language. This page is up to date. Okay, page not found. Yeah, shading. Searching. Ah, everything is a shading reference. Yeah, there it is. Shading language. Okay, there we go. We have the latest. We have the latest page. Does it? Let's see. Source color. Yeah, there it is. Now it has the source color. Okay, so how are we gonna do actual density? Well, I actually have no idea. Let's think about it. Well, one thing is that we have the normal. We have the normal of this point. You know what? We could find a middle point. Well, yeah, one thing is that we can actually get the normal. We can turn the normal. Yeah, I don't need the middle point because I have the normal. It's not going to be consistent with every. Yeah, it's not going to be consistent with every height, with every distance. But let's see what we can do. Oh, shit, I forgot about this. Wait. Can change in bottom left corner too. Oh, there's a thing in the bottom left corner. Ah, look at that. I didn't know that. Nice. I don't even have to change it in the like 4.2. Okay, sorry about that. Yeah, let's see the normal of the atmosphere actually. Let's see. Oh, I keep thinking that I need to code in like the external editor. All right, so yeah, let's submit this. Did I? Yeah, adding atmosphere. Well, kind of done, but atmosphere with fall off density. Okay, next thing. And then later we're gonna add shading. Add shading to atmosphere and planet. And yeah, and finally after this we're gonna add some sunrise bloom, or how would I say? Well, it's actually me scattering, but it's not. I'm not really going to do me scattering. I'm gonna do just kind of a fake me scattering. Okay. So anyway, let me submit this. So far, what do we have? So sky shader, what do I want? Added atmosphere. Added nice atmosphere. Equal density atmosphere. Let's be more precise. Okay. So let's actually output the normal of the sphere. Let's see. This is going to, how did I actually calculate the normal? Okay, I have to recalculate this. I have to recalculate the whole thing. Have the hit points. Well, I can actually remove this. Either hit normal, ground, UV. Yeah, I don't actually need ground UV. I'm gonna remove that. I'm gonna remove these old ones. And let's just, oh yeah, PT0. Let's not do PT0, let's do AT0. Okay, hit point and the atmosphere. Yeah, let's actually just output this. I'm gonna output it with color is hits normal. Okay, let's do a dot. A dot of view. What's the name of it again? Dear. And hit normal. Okay, let's see what we have. What do we get here? It's trying to put a float. So let's do this. We have something, but it's actually below. Is it? Yes. I think this should be minus. Yes. Oh, look at that. We have the distance now. We have the direct looking into the planet, and we have 0 at the atmosphere. So it's almost like, oh, look at this. Maybe I can just multiply these two. What if I do that? That gave me an idea. Normal is, let's just call this D or something, like a dot product. I can't name it dot because that's also the name of the function. So this is going to be the float D, and we're going to have a color is going to be added to this. What's the problem here? Oh, I'm trying to cast it into vec3. Let's not do that. And let's also clamp it just in case, although I don't think it will ever be below 0. 0, 1. Interestingly, that it actually takes in 0, 1 in the clamp, even though this is a float. Yeah, so let's just multiply this with distance. There we have some fall off now. But let's do that with a square, just like I did in the beginning. So now we have a square, but we have to increase. Let's do a multiplied by 10, something like that. Oh, look at that. Look at that. I mean, I'm just looking at the edge. I'm not looking. Whoa! Whoa! This surprisingly looks realistic. You know, I was actually thinking of adding some gradient, but this we don't have to implement any gradients actually. Look at that. This is actually surprisingly realistic. Okay, except that in this case, we need to make sure that this is not. Yeah, we actually have to do the fall off from the normal. Now, but look at that. This totally looks like an overexposed photo from space. Surprisingly. Okay, so how are we going to do this? Without the DDs, it actually looks pretty good on the Earth, right? Yeah, it does. It does look okay to me. So let's call this DD factor. The DD factor. Okay, we're gonna use the DD factor. Is gonna be this if. Wait, was this just multiplied with DD? Yeah. So here's what I can do for now. I can just say if intersecting planets do 1, okay, B1, and if not, just do this. Look at that. It actually looks pretty good, except that yeah, let's make it thinner. Let's make it a little thinner. Look at that. Nice. Looks really cool to be honest. But yeah, does it actually depend on my angle? You know, you're not actually, oh yeah. Well, when you're inside the atmosphere, kind of everything breaks down. But we're not actually implementing being in the atmosphere. You're always going to be in the space anyway. Yeah, that looks good, except that the white should also be inside the planet. So not only outside. Let's reduce it a bit. Okay, there we have it. There we have it. I can slightly change. Making it more blue. I can make it a little bit more blue. And then increase the density. Okay, that doesn't look bad. Doesn't look bad at all. All right, but let's see from a little further away. This actually surprisingly looks consistent on any distance. Okay, let's add a little bit of inside. Can we? Oh my God! I can just increase this factor and that's it. Okay, I think I'm done with my planet shader. This actually looks really good. This looks really good. Wow. Okay, I'm actually surprised this looks this good. I'm not even doing any Rayleigh scattering or any kind of crazy scattering thing. This is just dot products, and it surprisingly looks good. I'm actually surprised this looks really good. Okay. So yeah, there we go. Planetary shading in a few dot products. Look at that. That's actually amazing. Okay, well, I'm gonna make the atmosphere a little bit thinner still. Let's see. Yeah, but you do have to adjust sort of for every density. Okay, well, the only thing that we're missing now is, yeah, this is amazing. I'm still kind of shocked. I'm still shocked that this works, that I didn't have to do any crazy scattering formulas, because this is enough for me. Okay, if I was doing like a serious simulation, I would do scattering, but this is totally fine. This just looks good to me, and that's it. Okay. Look at that. Look at that. Let's actually see how it looks like from inside the world. Look, let's go to the Great Lakes and look at the ocean. Let's try in game. Oh, it doesn't look actually that good. The atmosphere. Okay, so I basically need to manipulate this multiplier every time. Okay, let's go with let's add that as a uniform float. Rim multiplier, let's call it a rim mult, and I'm gonna put it to like 100 for the beginning. Okay, rim mult, and then I'm gonna have a interior. How do you call the not rim part? The not rim mult. No, a middle. Let's just call it mid mult. Okay, and what is it by default? It is actually 5. Okay, 5. There we go. I'm just gonna replace this rim mult, and this is gonna be the mid mult. Here we go. Okay, so now I can just change it here, right? And just set it to 500. There we go. If I want to just increase it a bit. Mid mult. Yeah, and then if I want to increase the inside, there we go. Yeah, if I reduce it, doesn't look good. I need to make it close to the atmosphere, to the rim. Cool. Okay, let's try it in game. And look at that. It actually reflects, the planet reflects onto our space station. Let's see it from the cupola actually. I'm gonna move it up. Oh, well, this is now the, yeah, I need to actually also add some rotation as well. Well, this is not good. Okay, let's redo it. Okay. Oh, and the sun is actually over there. All right, let me run the game and see how it looks like in game. Good thing is I don't really see any adverse performance, so I guess that's okay. Although I didn't really. Oh, okay. So this is looking into the sky. Let's not look at the sky yet. Okay, let's try to spare myself. I don't want to look at the sky. I want to go into the cupola and look at it from there. Oh, look at that! Oh, here it is. Here is my first look. It's the planet and it's pixelated. Oh, can I actually see? There's a Z fighting that I need to fix. Can I actually see it from my room? Boom. From the crew compartment. Oh my god. Look at that. Oh. Imagine this is the beginning of the game. Sorry for that little orgasm. This is the beginning and you see the rim. Oh, wow, that looks amazing. That looks surprisingly realistic. I can see that the fall off is not exactly realistic, you know, but it even seems like there is a little bit of like scattering, like it's a little bit reddish in the middle, but maybe that's just my eyes are, you know, tricking me because of such blueness. Let's look at it through the cupola. Look at that. There we go. Well, in reality, the Earth is over there in cupola because cupola is always looking down. But here we go, and we can even make we have the sun disk as well. Nice. This really feels like space now. Okay, so now that we know that it works, what we're gonna do is let's first fork this. And let's see. So, surprisingly good looking atmosphere. Okay, there we go. Okay, now it's time for shading. Atmosphere with fall off, perfect. Add shading to atmosphere and planet. Yes. So, let's see. Shading. Let's re-add what I had over there. Where is the shader editor? So what I actually had before was I put this out light, yeah. So light, hit normal, and I'm gonna, yeah, let's remove that. I'm multiplying with light. There we go. We are multiplying, and well, the atmosphere is not lit. So since we have the light in the atmosphere as well, let's do this. Let's just add. We have the normals. We have everything. We have everything we need. We can just multiply everything in the end with light. Let's see what happens. Oh my God! Look at that. We already have shadows and everything. It would be cool to now have some normals on the for the yeah, some normal mapping for the mountains. Maybe for the next stream, maybe not now. Yeah, well, you can see that it's completely fake, because in real life this rim looks a lot better. Like there's actually some there is a little bit of fall off. Well, we can actually fake that as well by just adding a little bit of a gradient on there for some scattering gradient. But yeah, now we can move the, let's rotate the sun. Let's rotate the sun. Yeah, nice. Except that, yeah, it looks terrible. It looks terrible because this is not how, the sun is rising, but there's no sun on there. Yeah, but there we go. It actually totally works. We see the shadow part. Amazing. Well, I can actually end it here now, because I've just solved everything. But yeah, I do actually want to implement a little bit of sunrise and sunsets. So here's the thing. When the sun sets, what happens? Oh yeah, let's make the sun a lot brighter. Let's make the sun brighter. Let's call this. Let's actually call this the sun disk. Oh, it's actually a vector 3. No, let's not do a vector. Let's just do this. It's going to be the sun disk, and then this is going to be the sun disk. Is it the disk or this? Is it with a C or a K? I never know that. I think it should be C as a shape. Disk with a K is more like a hard drive kind of disk. Okay. So yeah, sun disk, and what I can do is instead of clamping this, I'm going to multiply it. Let's see if that bloom actually works. Ah, there is a little bit of bloom. And this, okay, so we have some bloom. It actually works, but Godot bloom is awful. Godot bloom looks terrible, I have to say. Okay. Well, let's actually make it smaller as well. Yeah, that looks more like the sun. Okay, maybe I can make it slightly bigger. Okay. And what if I make it really bright? Okay. Well, we have something. We have something that kind of looks like the sun. Okay, so what happens now if we hide it behind? Okay, well, yeah, it looks terrible. Okay, so what I can do is I can do another dot. Well, we already have the dot. Okay, well, okay, let's do a sun dot separately. So the sun dot is going to be this. And I'm gonna put it here, but let's actually output the sun dot just so that I can see it. Yeah, so I'm going to use this one for a little bit of fake me scattering, and let's push it. Yeah, how would I do this? How would I do this? Maybe I can multiply. Aha, I can add into the DD, perhaps. Perhaps. Let's try this. Whoops, sorry, knocked my microphone again. Let's try to end this. Let's see. Sun. Yeah, let's call this sun scatter. And that's gonna be the vec3 sun dot. Okay. Oops, why am I vectoring here? Okay, and I'm gonna change it over there. So I'm gonna do a plus equals that. So yeah, there it is. We have something. We have something that we can see. Let me also output the sun disk, so that I can see it. Yeah, let's do the sun disk like this. All right, and so yeah, sun dot. Let's do. You know what? Let me output sun scatter. Sun scatter for the beginning. Okay, and let's turn the sun scatter. Okay, what if I square it? What happens then? Okay, maybe what if I cube it? Okay, that doesn't change much. So I'm just going to push it slightly, again by some margin, like this, and I'm gonna clamp it. Let's make sure that it's always clamped between 0 and 1. Doesn't work because, is it because of this? No, it's because I forgot an operator. Okay, here we go. I don't need this, right, in a clamp function. No. Okay, so I can push it away slightly, make it smaller. Something like this. All right. And wait a minute. How does minus... because this is a... Yeah, okay, let me... Because this is a power. Okay, so there we go. Okay, we have this, and it should... I should be able to see the sunrise. Yeah, interestingly that it actually pushes... It doesn't push the opposite. Okay, let's now add this into, let's add the sun scatter. Let's not put it here, but I'm gonna add the sun scatter into the DD. Okay, sun scatter, but I'm gonna increase it by maybe 10 times. Let's see. Aha, there we go. We have some sunrise glow of the atmosphere. Let's see. Let's see. Where's the sun? Okay. Okay. Oh, we can actually really see the transition between the two. Oh no, that's terrible. It's like, oh, sun is getting closer. Light up the atmosphere. Yeah. Yeah, actually, this we need some kind of a rim light there. That's the thing. It should, yeah, it should extend the atmosphere. Yeah, this is not happening. Okay, let's not add this to DD. Let's add scatter after everything. Let's see what happens then. Aha. This is even worse. No, actually, this is something that I could, yeah. Maybe this is something that I can work with. Interesting. How am I going to do this? I have to blend. I have to blend a little bit of color inside this. Let's zoom in into everything. Okay, so that I can see it a little bit better. You know, let's actually flip this around. I want to make it so the problem is right now, because we have this okay, let's not use a Let's not use a power. Okay. This is even worse. Yeah, the problem is that I actually want to flip it around. So this is what I want. I want to flip around the sun dot, and then I'm gonna power it. Okay, let's see if this even works. If my math is flawless. And then I'm gonna flip it around again. So what I'm trying to do is I'm trying to flip around the curve. And then we can do this. And then I can pass this sun scatter. Ah! Yeah, this doesn't work. It doesn't work like this. You can't just simply flip around a power and yeah. Okay, so my logic is not flawless. Okay, let's go back to sun dot. Oh, and now this needs to be initialized, of course. Okay, well, let's make this better. Maybe I need to blend between the DD and my color instead of adding it on top. Right? So let's go back to adding it to the DD. It does look good. I do like how this looks like. But what if you do this? Okay. Yeah, this actually looks cool. But the problem is, yeah, the problem is actually in that I want to make this visible slightly outside of, yeah, I need to push the normal a bit of the light. That's the thing. That's the thing. So what if I push the normal away like this? Hey, this is actually what I want. Okay. So yeah, the shading should start a little bit beyond. What if I push it even more? We're getting there. We're getting somewhere. Maybe this is a bit too much now. We have nothing, and then we have too much. No, this actually still looks good. I mean, at the shade. So we're like pushing the wrap around. Yeah, this still looks terrible. The sunrise. Sunrise is awful. Because it needs to be shining on top and not multiplied. It still needs to let's actually push it even more. What happens if I put it 0.5? This looks slightly better. Maybe I should blend with something like this. Yeah, there, we don't see the sunrise now going up. So basically what I want to do is I want to blend this. I want to take this light. Okay, so we're gonna have another light. We're gonna say sunrise light. Okay, and this sunrise light is gonna be pushed more than this. I am still going to push this one. It does look better when the atmosphere comes first. So if I have just 0 here, right? The atmosphere is like shorter. Okay, let's not add this for now. So here is the problem, right? The atmosphere is actually shorter than the planet. The planet is brighter here than the atmosphere. So by pushing the normal, the dot a bit, what I get is that I get this atmosphere now gets over the dark areas. Nice. Much better. Much better. Okay. But yeah, I need to add a little bit of more rim here of the atmosphere. Nice. Oh, well, on the back side it looks a bit weird, no? If you're looking back. No, it still looks good. Still looks good. Okay. So now I just want to add this a little bit of rim. And yeah, so here it is. I can do a DD, but this is gonna be multiplied by sunrise light. All right. Something like this. Something like that. Yeah, looks good. Looks good. DD. Yeah, maybe this light shouldn't be here. Instead, it should be in the DD. Okay, let's multiply that. Okay, so we have now light. And on top of that, we have the sunrise. And that looks terrible. That looks terrible, of course. It looks great. It looks great when the sun is low. It looks great when the sun is low. But once it gets bigger, how do I say it, taller, then it sucks. Totally sucks. Totally sucks. Okay, so I basically need to make it, I need to kill it once it gets over a certain distance. But I need to do that smoothly. I need to do it smoothly enough so that it's not visible. Not too visible. How do I do this? How do I do this? Yeah, this is actually way too, the shadow I think is way too long now. Let's not offset light so much. 5. Yeah, it should be enough to cover the rising sun. Like this. Where's the sun now? Give me the sun. Yeah, something like this. Okay, and now I have to blend. Blend the two. So we have a dot between the normal and the light, and I'm multiplying it. What happens if I don't? Aha, that is actually increasing. Oh, it's actually greatly influencing the distance. Oh, I think this actually helps. This actually helps to not put it at 1. Ah, maybe this was the problem all along. That I've forgotten that I have multiplied the atmosphere. All along, I had this multiplied. Yeah, I wanted to make the atmosphere sharper, but that's actually killed. Oh, look at that! We have 2 levels of that. This even looks realistic, like, because in real life you have like you can see sometimes different layers of atmosphere. This is funny. Yeah, if you look like sunset from space, you can see this, like, yeah, because sometimes because of the clouds, you can see like different layers, right? Because, well, there's a cloud shadow in this one. Yeah, but if you look at some, yeah, like this one, there are some images where you can clearly see the ozone layer on top. Yeah, not in this one, but there are some where you can see, yeah, like this. Well, we can't see in this one, but yeah, this is what I'm trying to achieve, sort of. The usual solution in this case is to ray march through the direction of the sun to check how many times it crosses inside, blocked by the planet, applying attenuation based on the points that is inside the atmosphere. Sorry if I was too obvious. Just enter the stream. Yes, this is what I'm trying to avoid. Like, yeah, this is like, it's not that I'm trying to avoid. I'm just trying to simplify it, right? That's what I'm trying to. This code has no Rayleigh scattering at all. Okay, this is just dot products. I have like intersecting sphere. I have mapping UV, of course, to a equal area sphere, and that's basically it. And then everything else is dots, and I'm actually surprised that it looks so good just by manipulating color and dot products, you know. So I want to do it this way, but look at that, it actually looks already good. The only problem is that you can see this difference between the sun. Yeah, this is now my only problem. I just want to eliminate this obvious fall off. So yeah, what do you know what I actually want? I want a formula. I want a formula that is, yeah, okay, let me show you. Okay, we have x. We have x power, right? The x power goes from 0 to like, goes up. And then if we clamp this, as we do, clamp to 0, does this work? No, wait. Oh yeah, there's no clamp in Desmos. Okay, well, I'm gonna have to use min. No, let's just use max. No, min 1, right? Yeah. Okay. So yeah, the reason why we have this is because the reason why we have this visible line is because of this corner over here. So I just want to kill this corner. What about 10? No. What can I do? How can I kill this? Can I do, oh, look, a sine wave. I could do a sine wave to remove this. What happens if you do a sine wave? but then I have to also saturate it. Let's try doing a sine wave of the sun scatter. So instead of the pure dot, I'm just gonna apply a sine. Well, it's still visible. Okay, let's actually output only this. Color is sun scatter. Color is sun scatter. No, because it needs to be wrapped into a vec3, of course. Yes. So, I want to make it very bright in the middle. Yeah, actually I want to do a... Wait a minute. Okay. Let's see this. Float sun scatter is sin sun dot. What happens here? Okay. Hello. Oh no, I'm being rated. Hello. Nice raid. Thank you. I'm trying to make a nice planet shader with code. So if you can see it here. But yeah, right now it's a little bit broken. Oh, nice bloom. Okay, yeah, if I replace this with this, it should work. Yeah, it looks nice. It looks nice so far. You have a planet. There is a space station. But oh, it just got deselected again. The sun. Yeah, the problem is this this transition. It looks too sharp. I just want to kill this transition. Okay. Just want to kill this obvious transition between the setting sun and the non-setting sun. But everything else is okay. Everything else is okay. So, what I really want to do is this working? Why is this not working? Because I'm not outputting this. Cool. We were looking at similar stuff on Shader Toy earlier. Oh, really? And this is just I'm not even doing any relay scattering or anything. This is just dot products and faking it with color, because I don't need I don't want anything advanced. Okay. So yeah, I want to turn this into a differently. I want to sharpen it in the middle. Let's see. Let's try to do this. No, not that. So, sine wave, not great. Sun dot. Yeah, let's always clamp this to 0, 1. But now I'm going to play around with the dot. So, if I multiply it by some number, what do I get? Okay, I get a bigger one. No, I actually need to push it to make it smaller. Here's the thing. Yes, but it gets dimmer. So I need to, yeah, basically I need to turn dot from this into this. I want this curve. That is not this. Wait a minute. How come it is? Dot. That doesn't make any sense. It still looks linear to me. Adding this doesn't change anything. Yeah, it still looks like a sphere. I don't want a sphere. I don't want the sphere. I guess what I want is something that looks like this. Right? I'm actually a little bit confused here. Because... What happens if I do a 0, 4, minus? No, this is probably not correct. Yeah, this just turns it upside down. Okay, but what if I power this one? Oh, it's on the other side. Yeah, it just flips to the other side. That's the thing. Oh no, I am actually getting a different fall off. Hey, this is actually working. Okay, this is what I want. This is actually what I want. Is it gonna be smaller? No, it's not gonna be smaller. Okay, what if I just do minus? Okay. Okay. What if I increase the power? Ah, there we go. Yeah. Is this not the same thing that I was already doing, but on the other side? Yeah, it is the same thing. Okay, I am confused. What if I do 10? Oh, it's not gonna do a... Offset that. I'm just gonna flip around all the possible. Yeah, this is not it. Okay, what do I actually want? But this is 0. This is 0. Okay, let me rethink this. Okay, this is where my head starts hurting. Yeah, not SanDisk, SanDot. Okay, so this is 0, this is 1. This is 0, this is 1, and this is x. Okay, what I want is the 0 to delay the 0. That's exactly what's happening. Why does it not look like that? Oh, it does look like that. Of course, I need to clamp. Nice, nice bright space station. Yeah, I am actually surprised by. There's something weird going on there. Okay, let's just make it. And of course, I need to clamp it. It still looks like it's the opposite. It's the other way around. It still looks to me as if it's doing this instead of this. What the hell? Well, the good thing is that it's always between 0 and 1. Okay, let's try this. Let's try this. Sun scatter. Okay, let's plug that in. Although it doesn't look to me as if it works at all. Sun scatter. Okay, but how do I make it? What's 1 by x? That's probably not what I need, but let's try. Let's try this. Oh, not power. Yeah, this is definitely not what I'm trying to do, I think. Let's make it smaller. No. Definitely not what I'm trying to do. It's definitely the power. But I need to scale it down. And this does not really work because it gets dimmer. Why does it get dimmer if I do a, can I do a power? No? Oh yeah, you do it like like this. Okay, so I do a 9 and then I multiply by some number. Yeah, it offsets it. That's the thing. It's not 1 anymore. Okay, well, I can actually just modify the input, right? Yes, this is how you do it. Okay, I'm done. Yeah, I should actually add it here. If I add it to 0.5, yes, and now I can multiply by 0.5. No, well, by how much I actually need to multiply now? I have to multiply by... it's not anymore 0.5. Yeah, it's gonna be like 0.25. I see. So this is the... Okay. Yeah, something like this. I think so. What is this? What is is this the root? Let's see if Google tells me anything. What is as a fraction? One by 40. There's got to be, it's definitely a square root of something. So if I make it half, there's got to be a formula to make this always... But wait, isn't it the same now? Isn't it the same or is it not? Actually, it's not. Actually, I'm changing the fall off with this. Definitely not the same. Yeah, well, actually what I'm actually just trying to do is push this away. So I can just do minus 0. Yeah, well, I just push it by minusing it something. Yeah, the problem is it's clamped. Okay. That's the problem. Okay. I'm too dumb for this maths. Maybe, here's the thing. Here's the thing. I'm just gonna add a gradient or something. Okay, is there a gradient in Godot? There must be. Probably not like this. Uniform, I don't know. Godot uniform gradient. Get gradient color. Okay, you simply take a, but can you, is there a gradient hint or something? Gradient. Performs the texture with split its gradients. No. Is there a way to, oh, I think that actually it exists in Godot as a type. Okay, let's see. Uniform sampler. I think you just make it a texture. And then you say sunrise gradient. Let's try this. Let's try this. And then I'm gonna simply take, instead of doing this, I'm gonna still clamp. I'm gonna still clamp, but I'm just gonna take a sun dot. I'm just gonna take a sun dot, but I'm gonna texture sunrise gradient. And the X, yeah, I'm just gonna vec2. This is gonna be that, and this is gonna be 0, 5, right? Somewhere in the middle. Somewhere in the middle of a texture. Vec3 to float. Vec3 to float. What's the problem? What's the problem? What's the problem? You type gradient instead of gradient. 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 Yes. Sunrise gradient. Except that I made a mistake twice. Thanks for catching this. And what is going on here? Vector 4 to float. What? Vector. The texture read is a vector float. So I guess you need to grab a RGB. No? XYZ? Oh, it's a scatter. Okay, so it's just X. There we go. Okay, but we don't have a gradient texture. So why? But why is it white? It shouldn't be white. Am I outputting the sun scatter? Yes. Texture sunrise gradient. All right. Let's go out of this mode. Environment. I'm gonna add a new gradient. Shadow. Ground texture. No, not that one. Let's pass it a gradient. Okay, new gradient texture 1D. There it is. There it is. Yes, I know that it does have. Okay, width. We don't need this width. We can do 64. Oh, look at that. There's a hole in the middle. Okay, so the gradient. Yes, look at that. We can now push. We can make our own. Oh, look at that. We can make our own fall off now. Okay, so let's make this gray, but I'm gonna push the gray down. Interpolation. Is there a cubic interpolation? Can we make this? It still looks terrible. Raw data, even if it's cubic. Okay, why is there a black dot in the middle? Why is there a black dot in the middle? Because it repeats, that's why. I need to clamp it. Okay, maybe I can do like clamp between 0 and, oh yeah, also this. Yeah, everything on the other side is white. 099. Okay, there we go. We solved that part. Okay, there we go. Okay, let's make sure that, yeah, that black, it's not black in the middle. Okay, well, yeah, I wish that it was, fall off was a little nicer. That it was actually cubic. Okay, something like, yeah, it's not great. Maybe I'm gonna have to make a special texture in Photoshop, like, instead of this gradient. Oh, what is this? Oh, that's flip around. Okay. So, sun scatter. Okay, let's try it with the whole thing. Let's try the whole thing. It does use sun scatter. Look at that. Look at that. And, well, there's a little bit. There's a little bit of... there's a little bit of noticeable thing, but not as much as we had before. Yeah, this looks good. I'm gonna call it done. Should I call it done? Yeah, this can be improved a lot, but I like this. Well, let's push it a bit. Let's push it a bit more. Sunrise light. So yeah, I pushed it here. And then push this. Yeah, the problem is that the more I push the sunrise, I'm gonna have a worse thing later. You know, maybe this is not. Maybe nobody's gonna even notice this. Like. That looks really good. That looks really good. But yeah, there is this like bands from the gradient texture, which look terrible, but why not? I don't know. Why not? Yeah, except that it's definitely way too strong. I like this. I like this. Okay. Look at that. In real life, it even looks worse in real life. Okay, maybe I can push it slightly less. There it is. Okay, very delicate balance. But it doesn't hide the sun. I need to hide the sun. That's the problem. I need to hide the sun. Okay, let's do like 0.18 magic. There it is. Something like this. Something like this. And you know, I can also make the sun like yellow or something. But hey, this looks pretty good for it being okay. So I'm actually adding this on top. What if I multiply? Just let's see what happens. Yeah, Hey, that doesn't even look bad with multiplying. But what if I min it or max it? Yeah, I don't know if this looks better or worse. Well, in real life, lights are additive. They don't really. There's not many things in nature that mins and maxes. It's either multiplication or adding. So I think this should also multiply. Or add. Yeah, maybe it's just all about adjusting. Yeah, it is way, it's actually, yeah. It's too bright now. Let's reduce it. See if I still have this sunrise. Okay, well, the sunrise still works. Hey, that looks a lot better. You can still see that light traveling, but this looks a lot better. Yeah. I'm gonna say that this is done. Okay, maybe push it slightly now. No, less push looks better. Yeah, now I can actually play around with that texture that I'm pushing into the atmosphere. Yeah, this is the issue, is that this is not really a cubic fall off. Look at that. There we go. And we have a little sunrise. It would be great now if it was like red. You know what? What if I add some color? No. Okay, what if I add some color into the gradient? Huh? Shit. I'm already going too far. DD is a float. There's not really a lot of color, even in real life. Here's the thing. Where is my... Yeah, this is where I'm getting scatter. Okay, let's do this. Let's make this a color instead. And I'm gonna make it RGB. Does RGB actually work? It does. Okay. So sun scatter, this. I'm gonna multiply. Yeah, I'm not gonna add DD. Instead, I'm gonna vec3 sunrise. Let's just do sunrise. And that's gonna be by 30. Sunrise light. Oh, right. What is sunrise light? I even forgot. Ah, that's the one that like clamps it. Okay. So yes, sunrise. Let's then add into DD here. Aha. Okay, cool. Nothing has changed. Nothing has changed. But now, the cool thing about this is that we have color. We have color in our gradient. And I can simply, boom. Oh! That's terrible. Okay, let's do some orange. Okay, well, I can actually, yeah, this doesn't look that great. Some yellow. Okay, let's do HSV better. Yeah, the moment you add color, you change everything. What if I make this band red or something? Ooh, look at that. We're adding a little bit of redness at the rim. That might not actually look that bad. Ooh, oh, yeah, that actually looks terrible when the sun rises. When the sun rises, yeah, it kind of looks cool, but then you realize that, yeah, well, this should be dependent on the dot of the sun, I guess. But maybe a little bit of, yeah, a little bit of a narrow band would be okay. Yeah, let's remove the color from here. Let's remove the color from here. Okay. Well, let's try to use this one. Yeah. Mixing with yellow doesn't actually look that good. I wish I could zoom in and into this gradient. Okay, well, yeah, you can stretch the whole thing. Okay, maybe something like this. Maybe something like this. Yeah, well, you can't really see the colors, but it doesn't matter. I think it looks good. I think it looks good. I think it looks decent. Now at least we don't see we see we see the disk again. We see the disk again. Oh no. Maybe it's because I changed the colors. Yeah, it's way too bright, the atmosphere here. I'm gonna have to draw it back. But you know what? This actually looks really good. Like even without the proper... yeah, I think that in the game it's gonna be looking fine anyway. Yeah, I need to fix this mixing for sure of the sunrise. Yeah, because it's way too bright here. when it's, yeah. Yeah, I need to kill it when it rises. I only want to have it like in this case here. It becomes too bright after a while. Okay. So, I think this is a success. Let's try it in game. Oh, and I'm definitely gonna have to add rotation. Okay, let's add the sunrise and let's see how it looks like in game. If it looks annoying or not. Well, what will look annoying, I think, is this bloom. This bloom is just awful. Godot bloom. Yeah. Great. What is going on with the sun? Ah, okay, the sun is over there. Yeah, I need to now rotate the light as well. Okay. But here's the thing: the spaceship is gonna fly around the Earth. So the spaceship, well, the spaceship. By spaceship, I mean the station. Okay, well, this is again the wrong. I always take the wrong direction. Yeah, let's look through some windows. I don't see it there. There's nothing there. Complete darkness. Oh, there's the rim. There's the light. Cool. Cool. Okay. Cool. Where's the cupola? I always I never can find it. There it is. Okay, it's over there. All right. Nice view of the sunset. And yeah, this the sun just looks awful. But that's what Godot offers you. Yeah, such a beautiful. Yeah, you can see this fall off. But yeah, I think it's pretty good. I think it's pretty good. That looks realistic to me, even if I haven't been to space before in real life. Yeah, I might have pushed the atmosphere a bit too much behind. Oh yeah, I can actually move the sun live, and it will turn around in game. Yeah. Oh yeah, cool. I don't need to make a sun rotating keys. Yeah, this looks terrible. This doesn't look great. But actually, it's due to the bloom. Yeah, I definitely need to add a little bit more formulas there. But I'm not gonna do it now. Okay, there's the sunrise. So beautiful. Now let's put it all over on top. Nice. You can see the whole planet. Oh, and look at that. The reflections. It actually reflects onto the station. Nice. There we go. Okay. So, one more thing that I need to add. So, here's my problem. I have a little bit of a problem again. The problem is that my station can't rotate because it's static. So instead of in real life, if I was actually in the like universal reference system, I could just take my thing. I could just take my position, right? Where is it? There it is. And I could just I could just play around with the position and make it go into circles, and I would fly around. That would be simple. But in my case, I actually need to make it rotate. I need to make the planet rotate because the space station is supposed to be locked into one rotation, like this. And I actually want to scroll the texture and not change the position of the planet, right? Well, not scroll the texture. That's a bad idea. I just want to rotate basically the normal. Okay, so how do I rotate? Adding atmosphere, planet, sunrise, done. Rotation. Planet rotation. Okay, well, we need some kind of a rotate. Yeah, let me also add that into here. Simplified. Yeah, let's just see. Fake Mia scattering. Okay, so how do I rotate the planet? Well, I can simply rotate the normal. Before I pass it into here, right? Into sphere map to, I can rotate this normal. And how do you rotate the normal? Outer product. I don't know. Does Godot have rotate? Godot rotate around axis or something. Shader. Rotating around the y-axis. Rotate about axis. Unity. Well, this is not. Oh wait. It actually has code. Radians, degrees. You know what? Hello, Unity. Can I steal something from you? Can I steal a little bit of a function from you? Rotate axis, let's call it like that. Vec3, float, vec3, float, matrix. Matrix is mat3. And I think that mul doesn't exist in GLSL. What is this? Invalid assignment of float 9 to mat3. How do we actually initialize mat3? Do you initialize it with 3 vectors? It should be mat3. Ah, that actually worked. Wow, I'm surprised. So yeah, multiplication doesn't work. I think it's you do this. There we go. There we go. Where is my rotate axis? Rotate axis. Okay, let's try this before I pass it into this. Rotate axis. Oh, it actually returns nothing. Why does it have an out? Why does it just not return this? Return vec3, please. Return. Okay. Okay, let's go around the up axis. Rotation, I don't know. Let's do 1 for the beginning. And that's it. I think it worked. I think it works. Yay! Yes, I think it works. Okay, cool. Let's add some kind of a rotation vector. I'm gonna do a 2 component vector. Rotate. Rotation. Planet rotation. Let's do it like this. We have center, we have rotation, and I'm gonna take rotation and let's put that into Is this the only? No, I'm not using the same thing. Okay. So this is gonna be planet rotation. Okay, up axis, planet rotation X. Okay, let's try. Planet rotation. There we go. Whoa, 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 whoa. It works. Cool. So what we can do now is we can simply rotate the planet like this, and it's gonna be like I'm moving across the planet. Okay, let's add a new rotated normal, and that's gonna be this rotated normal. Like this. Does it work? Yes, it does. And I can do it in the other, let's do X rotation as well. Let's see what happens here. Planet rotation Y. Oh, that should be rotated normal. Okay, so do we have 2 vectors now? X, Y. Nice. Does this actually make sense? Okay, we're always going to the pole. No, actually it should be, maybe it should be the other way around. Okay, let's do vec3 rotated normal is hit normal, and then I can do like this. Okay, that's one thing, and I can now just replace them. Okay, let's see if does this make sense. Okay, so this one is always rotating around the whole globe now, right? Not sure, not sure. I think so. I think so. Let's see. Yeah, this one makes sure that we're going forward across the whole globe. Okay, so this is like the inclination. Basically, I'm picking an inclination and then I'm just rotating. Ah, yeah, but I'm going to have another rotation as well. Yeah, something like this. But yeah, it also depends on where I am. If I was on the top, if it was exactly on the middle, like here, yeah, I would still fly over the Antarctic every time. So that's not great. This is cool. Flying over Africa. Is this Africa? I think so. Oh no, this is Africa. This is Antarctic. No, no, this is Australia. Nice. Okay, yeah, you're so close to the planet that I don't recognize continents. Nice. And there we go. Okay, yeah, I'm definitely gonna have to have 3D rotation, I think. 3D rotation. Okay, let's make that a vec3. And vec3, it's gonna take another rotation. Maybe this. This is the inclination, and then you have the offset. Yeah. So here we go. We can rotate like this. Aha, this actually rotates as well. And sideways. So this one is actually the true rotation, I think. Yeah, except that I should rotate somewhere in the middle. Okay, there. We're flying over the US. We're still flying over the Arctic. Okay, if I offset that. Okay. I still can't get away from. Okay, now we're going somewhere. Okay, so this should actually be 0, I think. Yeah, now we are on the equator. It looks like it. Yeah. So this is the equator now. Yeah, this is the offset from basically the Arctic. So if it is half pi. Okay. There we go. There we go. Yeah, this should be a realistic inclination, I think. Wait, this is above equator. This is below. This is below equator. No, what? Australia, America. Yes. Okay, this is good. And then Africa. And then Australia. And then America. Okay. Yeah, this is a realistic inclination. Just need to find, yeah, the offset across Europe. Across Europe. Let's go across Europe. And through America. And yeah, this is not bad. We're not going over Russia anywhere. Anytime. Yeah, but the planet should rotate as well. So at some point we are going to be over Russia. Okay, so I'm actually going to modify the planet rotation Y. I'm going to advance it from code. Let's try if this works. I can see my house from here. Yeah, it has real life. It has real life resolution. Look, that's your house. This pixel. Maybe I'm correct. Maybe I'm not. Planet center. Oh, I'm inside a planet. Okay, yeah. Let's do something like this. And then if I keep modifying the planet when I actually want to modify this one. Okay. All right. Let's advance rotation. But here's the thing. The sun should also rotate. So it is kind of incorrect because we need to rotate the sun as well. I mean, it is correct. Yeah, I also need to have dimming from when the sun is behind. When the sun is behind the Earth, it should be night on the station as well. Okay, let's for the beginning just... Okay, so I have to leave in like 10 minutes, so I'm just going to implement... you know what? Let's actually put the planet above and beyond. Let's put it above. So that we have some nice... planet center. Wait, why can't I put it above? Oh no, there it is. It's just in light. What? Oh yeah, no, there it is. There it is. It's just that... Yeah, so that I can see it through the cupola. Yeah, but I have to change the sun to be below. I mean, yeah, it doesn't have to be at the center, that's the thing. The most important thing is that I'm just gonna rotate the planet through code. And let's make it a little bit of sunset. Just a little. Well, doesn't really look like sunset until it's too late. Okay, so we have New Zealand now. We have New Zealand. Yes, here's Spain. Here's Spain. Okay. So what I'm going to do, how do I even access this environment? How do I access this sky? Let's do, I don't know, let's call it Earth. Okay, well, I have to open it Expand folder, not expand, open in file manager. Okay, yes. Linspace Godot. I'm gonna start the solution file. Okay, so accessing Godot environment from script. Setting world environment in GD script. The get node part is front is world environment. Maybe I just get the shader or something. Yeah, well, let's see. Oh yeah, by the way, I was trying to make some handrails as well, but not complete. Okay, so I'm gonna put this as a child, and I'm gonna get a parent. Wait. Get parent environment. What does it say? Resource for the environment nodes. Oh, like world environment. So I think it's actually world environment. Yes. Dot environment. Yeah. Dot material. Dot. Now there's going to be a lot of dots, right? Because this is what's happening, right? We have a sky. Oh, it's actually the sky. Sky has a material, right? So, okay. Dot sky. Dot material. Sky material. Dot shader. No, well, I think it's actually sky material and then set parameter. Is there shader? Okay, so sky material can be any material, right? Or shader material. Sky material. But who has uniform? Can you set a uniform? Okay, we're gonna have this as a shader material is as shader material dot uniform. No, set. How do you set uniforms? Set shader parameter. Does actually this thing have set shader? No, it doesn't. Okay, only shader materials have. So string is, what's the string? It's called atmosphere color. No, it's actually planet rotation. Planet rotation. Okay, let's go with let's make a vector 3 here. Rotation. Okay, I'm gonna say get planet. Oh, get shader parameter. Does it have? No, it doesn't. Okay, planet rotation, and that's gonna be it's probably this variant. I knew it. As vector 3. So let's store it first. Okay, first I store it. No, it doesn't. It doesn't compile. Converts a string to a string name. Okay, so maybe this doesn't work. As vector 3. Okay, that's how you compile. As vector 3. Okay, and then in process, I'm gonna rotation y plus equals delta. Okay, let's make it super fast. Oh, and it doesn't work because it's a because it's a double. Okay, let's do a float cast. Okay, and finally we're just going to, okay, let's store the material as well. Shader material. Just gonna do this, and then we have material, and then material set shader parameter, planet rotation, and we're gonna set the rotation. Okay, let's see if this works. So environment, I'm gonna add a node. Gonna add an empty node. Okay, and this empty node is gonna have earth. All right, let's try. Let's see if it works. Moment of truth. Moment of truth. Oh, it works. And I know it works because the ambient light is flashing. Yeah, because I'm not using GI at the moment. Yeah. Let's see. Oh my god, look at that. We're flying. I need interstellar music. Okay, let's see in the oh no, this is the back. I keep mixing back and front. This is like everything should be shaking now, like an interstellar. Okay, let's look. Oh, there's nothing out there. Let's go into the cupola. Oh my god. All right, look at that. Nice. And of course, the sun is not rotating. Yeah, well, this is because I'm advancing in radians and not in degrees, right? That's why. Nice. Okay, and of course, the sun is as fast as we are. Okay. Well, let's first multiply that. Let's do a, yeah, instead of delta. Yeah, we can actually find out how fast it's gonna rotate. If you take orbital speed. Well, yeah, let's just do it like this. I'm just gonna do like approximately. This whole day was about approximately. Approximately doing things. Okay, let's look at this. Oh, I still am moving pretty fast. Yeah, it should actually be like 10 times slower than this. Let's lower the sun. Yeah, the sun is static. But yeah. Yeah, should be, I think, like this. Maybe somebody can do the maths. You can look for like search for like orbital speed. Well, okay, I can do that. Orbital speed at speed at 400. No, what 400 kilometers orbit, circular orbit. You can just plug in the height of the ISS, and it will compute its orbital period as an orbital speed as this. So if the period is 1.54 hours, right? We have the period. So how, if this is hours, 1 hours to seconds. Let's calculate seconds first. That is 5,544 seconds. And we can do, if this is 360 degrees, we can calculate, oh yeah, well, we can actually, yeah, if I do 360, right, it's 15. So 15 degrees per second. No, that's not true. Wait. No, it's the opposite. It's 360 by 5,000. So that's 006 degrees. Is that possible? That feels now too little. Maybe it was actually 15. No, 15 can't be possible. But yeah, this is degrees. It should be bigger than radians. So yeah, so if I take 2 pi, right? Then this should be it. This should be 0.00113. This is the rotation speed. If my approximate calculation is correct. So I was actually close to eyeballing it. Tell me if my maths is wrong or not. Maths. What does the surface of the Earth travel at? 3,000. Yeah, I think it is 3,000 because it's like 10,000 kilometers per hour or something like that. Okay, let's see how it looks like now. It's on the other side. I keep mixing the sides. It's really hard to see what's forward and what's backward. All right, yes. This is realistic speed, I would say. Yeah, well, now it would be great to calculate the sun rotation as well. But I have actually no idea. Yeah, if the Earth is rotating, we need to rotate the sun as well. Okay, let's do sun rotation and then you're 10 times slower is pretty damn accurate. Yeah, it's funny that it was I eyeballed approximately, and oh, I thought this was the moon or something. I was like, wait a minute, I didn't implement the moon, but this is just the other module shining in the light. Yeah, this bloom in Godot is just looks awful. I wish it was like shining really a lot. Okay. Nice. I wasn't thinking it's gonna look so good, to be honest. You can see that it's not very realistic because it's a little bit too blue. Like it should be brighter in the middle, in the like the atmosphere. Yeah. Anyway, let's make the sun also follow the planet. So, okay, let's get the sun as well. Let's do that in the same thing. Directory. Not directory. I need light. No, I'm gonna just grab a node 3D. Sun. Let's export. So that's gonna be on top. Okay, and now I'm gonna move the sun. Rotates by... Yeah, what if I just say rotation? I'm pretty sure that's gonna... Global rotation. I'm pretty sure that's gonna suck if I just put rotation like this. Because I think my order of rotation is incorrect. It's not the normal order. Let's see. Yeah, I need to make sure. Oh yeah, I need to run it first so that it compiles. And then I'm gonna assign the sun. The hand grab staying in 3D space looks so satisfying. Yeah. Yeah, I had this, I used to have this gizmo first. This is how I developed the game. And then later I added the UI. Thanks for that. By the way, let's move the player into the cupola so that I can see the world. You know what? Let's move the player outside. No, let's move it to the cupola. Let's not be unrealistic. Okay. Yeah, I need to compile that, and of course I have bugs because the sun should be here. There we have it. Let's see what happens. Aha. I see nothing, probably because I'm on the dark side. Yeah. Yeah, the sun is actually on the other side. So, yeah, this is gonna take some time to rotate. Wait, let's rotate. Let's actually start. Oh yeah, I need to go down, 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 planet center. Let's rotate somewhere else. Okay, the sun is somewhere there, but I still don't see the planet. Strange. Well, yeah, I don't have to rotate this much. What the hell? Wait, am I actually using... Yeah, I am using the rotation for the same thing. Yeah, this is hard to inspect now because I don't see it. I don't see it in real life. Where is it? In real life, I mean, in online. Here is what I'm gonna do. Can I take the initial rotation? That's not good. Yeah, let's sun original rotation. Sun dot rotation. Yeah. How do I actually offset this? Maybe I can just rotate actually by float rotate by. I can do something like this. Rotate by, and then instead of doing this, I can actually rotate around the axis. Yeah. How can I find the axis? But yeah. I don't know. Let's try vector 3 right. Angle in radians. Good. Rotate by. Okay, yeah, I would need to get being capable to edit the scene while in play. You know, it seems pretty important. Yes, that's my biggest gripe with Godot. Absolutely, absolutely. And all the other engines do that. only Godot doesn't. That sucks. Okay, so let's see, is it rotating? It's so slow. Oh, I can see the shadow. The shadow is moving. So here's the thing. We have to find... I have to find the axis around which my planet rotates. Okay. For now, I'm gonna speed up the gameplay. Okay. Does Godot... Oh, so does Godot have any plans to implement the game? I don't know. But I would love to, if that was... Okay. I think the sun is actually rotating around like y-axis or something. Okay, maybe I can just fake it. No, but it would be actually nice to have the actual rotation. The actual... Maybe in the shader I can do the same thing instead of doing this. Rotate by. Yeah, let's try not using right. Let's try up. Ah, I know what I can do. I can actually fake it by... I can fake it by childing it to something. Ah, there it is. We have some sun rotation, but it's rotating the other way. Nice. Okay, let's well, that means it's the other axis. It's the forward axis. I could do that, but I can also parent it to something. I'm guaranteed that I'm going forward, right? If I'm going forward, let me actually test. If I'm going forward, Yes, I'm guaranteed to go that I'm going forward. So that means, oh, that means it was correct. But my sun was actually sideways. That was the problem because it's not rotating when it's over here. Okay, let's kill rotation. Okay, there. Okay, so if this is the rotation, yeah, it should rotate around the right. And does it have rotate global? A unit specified rotates local transformation. Yeah, so here it is. If this is rotating locally, what I can do is I can simply add another node and to rotate around any other axis. But I think that this is the right axis. This is the right axis. Let's see. So it should be rising from me. Wait, these are reflections. Where is the real sun? Oh, I think that actually it's correct. Okay, let's wait for the sunset. Let's wait for the sunset. Okay. The sunset should be there. Oh, there it is. Oh my god. It actually works. I've seen my real sunset. Okay, and now it should die. It should not be light anymore. So, it totally works. Let's look at the sunrise on the other side. Ooh, what happened? Whoa, total darkness. Yeah, there it is. There's the sunrise. Ah, it's behind the module. Look at that. Look at that. It totally works. Nice. Cool. Well, yeah, it shouldn't be exactly on the equator. It should be a bit flipped around. But yeah, we'll have to add that. Nice. Okay. And of course, we have to do the sun occlusion from the planet. And I can also make it like orange. Or, I mean, the light, when it goes through the atmosphere, it should change the color. And then disappear completely. So yeah, I'm gonna end my stream here. I could rotate the light a bit. So yeah, let's make this a parent. Here's the thing. If I'm going around the Earth and the sun is sideways, then I should, yeah, it makes sense. Okay, let's do a child of this. Okay, mesh instance. Oh, I totally forgot that I actually have a mesh for the sun. We don't need that anymore. Okay, let's make sure that everything is okay. So this is gonna be sun root. Okay, I'm just gonna parent it, and then I'm gonna say that, okay, the sun, let's make it a little bit sideways so that I don't always go, forward. Yeah, I mean, it should also make sense in the state of the planet, but not for now. I mean, yeah, if I'm going on the equator, it depends. The inclination of the sun depends, of course, what orbit I am in. So if oh shit, not the sun root. The sun root shouldn't have rotation. The sun should have rotation. So when I'm rotating the sun, this is what happens, right? It goes up, and then it goes up to a point. It never goes over on the other side, right? This is perfect. Okay. And then goes down, and then it's behind, and yeah. Good. Okay. So yeah, but yeah, maybe it should be slightly more. Okay, something like this. Something like this. Maybe I can even start with the sunrise. Yeah. Okay, let's do it. Let's do it like this. So I'm going to rotate the sun root instead of the sun. Okay, and finally, yeah, I'm going to have to implement hiding, but that's gonna be for the next stream. Okay, let's look at the sunsets. Okay, so now the sun should be rotating not exactly as if I was on the equator. Look at that. Looks so good. Yeah, this is the reflections that you see are super weird. But yeah, oh, there's the sunset. I don't even see where the sun is. There it is. There's the sun. I just saw it for a moment. And now we're in dark. Except we need to kill the lights, of course. And yeah, and that means I should add some external lights as well. At least so that you can see a little bit. And then where is the... Oh, there's the sunrise. Somewhere there. Behind. Okay, here's the light. Okay, let's go outside. Can I go outside? Can I go outside? Where is the outside? Oh no, this is definitely... Oh, I can actually unlock this one. Ah, yeah, there we go. Yeah, let's spacewalk. Let's spacewalk. Ooh, there we go. Oh, it's actually nighttime. It's nighttime. Okay. My God, I really want to see this with SDFGI now, but yeah, I can't actually run SDFGI on this. There it is. Oh, sunrise. Sunrise. There's the sun. Nice. Beautiful. Look at that. Now let me actually detach from the station. Like I'm gone. I'm gone, and the time is passing by. Nice. And there we go. It's the sunset. That looks actually pretty amazing. It is lacking a little bit of color, but yeah, I am very, very satisfied to what I got today. Yeah, except that I need to make this dark. So on the next stream, I'm gonna make the station, like make the occlusion of the sun. But look at that, we're just flying through space. Beautiful. Okay. Yeah. Rest in peace. Exactly. Oh wait, I'm flying over. Oh no, that wasn't Antarctic. I thought it was Antarctic, but no, that was actually Africa. It's actually just so bright. I love that I love that you can actually see the reflection inside the space station. Although it should be blocked. The reflections should be blocked, but yeah, this thing is only annoying that you can see the sun disk. Yeah, so I should actually remove the sun disk from the cube map. This is why there is the cube map filter. Yeah, so there it works. It works. I can of course get this back to not have a 100 times bigger thing. Okay, so that now it's realistic, and that marks the end of the stream. Thanks for watching. Oh wow, just 34 viewers Impressive. Okay, so yeah, I can also put this up on the Earth shader. I can put it on GitHub or Gist or somewhere. Nice. Look at that. We have a sun. We have a sunset and oh, it's actually a sunrise. It's not the sunset. And the Earth is moving. I was actually thinking maybe of putting just a static image of Earth, but then I thought that's gonna be boring. And I thought, you know, maybe it's not that hard to make a planet shader. And there, I proved it to myself that it's not that actually hard, even if you're faking everything. It can look good. Okay, so yeah, that's it. Thanks for watching. See you next time. I don't know when it's gonna be. It might actually be. Oh, there's these compression artifacts that I actually really like. Might be actually after I come back home, even today. I don't know, because there's a few things that I want to finish with the planet shader. Okay, yeah. I don't know if there's like a better bloom also for Godot. Maybe there is. Maybe somebody did make it. Okay. There we go. Thanks for watching. Goodbye.